Hi students, so this is a follow-up video of my previous video on lights and molecules where I discussed how light interacts with matter and how light is absorbed by molecules, and this is what is responsible for giving the molecules or a solution's matter their color. From the previous video, what I explained was the principle of light absorption. Any molecule that can absorb light can do so because it has electrons. These electrons are present at a specific energy gap from the nucleus, and they have places where they can go to slightly farther away from the nuclei. That position would require a higher amount of energy. So if the energy of the light corresponds to the energy gap between the current place of the electron and where it wants to go, then that electron can absorb that light and move to the higher energy level. The question is, why do I need to study this? Now, the interesting thing is, so light absorption depends on the number of electrons that are present in this particular conformation in the molecule. The number of electrons in a particular solution will depend on the number of molecules that are present in that solution or object. The number of molecules that are present in that solution or object would depend on A, concentration of the molecule, which means number of molecules present per unit volume. It also depends on the distance traveled by the light within that solution. To explain this last point, let me take you through this diagram. Now, if I take a container which contains asymmetric depth, that means one edge end is deeper than the other, then if I fill it with a colored solution, say a potassium permanganate solution, what you will see that the color of the solution is lighter on this end, which has lesser depth, and darker on this end, which has more depth. Why is this so? This is because when light is traveling through the container, it is crossing larger number of molecules on the side which has more depth. So more of the light is getting absorbed, therefore the solution appears darker. Simple, right? Now this phenomena was explained by Johann Lambert in the 1700s, where he said that absorption is directly proportional to the path length of light through the solution. 100 years later, August Beer said that absorption also depends on the concentration of the solution. Combining these two statements, we get the Beer-Lambert's law, which states that absorption is directly proportional to the concentration of the solution and the path of light through the solution. So if we keep the path length constant, absorption becomes directly proportional to the concentration of the solution, which means if I keep changing the concentration of the solution, the absorption will change proportionately. So if we keep the length of the path of light constant, then the concentration of the solution can be determined by measuring its absorbance. Now, how do I measure this light absorption? The measurement is done using a spectrophotometer, or if I'm dealing only with colored solutions, it is called a colorimeter. These instruments have a very basic setup. They have a light source. This light source is going to provide the visible light or the ultraviolet light, which we are going to use, which my molecule is going to absorb. Now, this is going to give me the entire spectra of light. I don't need the entire spectra. I need a specific wavelength, which my molecule will absorb. So I use a wavelength selector. This wavelength selector can be either a filter or a monochromator. This wavelength selector will now select a specific wavelength. In this case, I have shown green light. And this green light has a certain intensity, which I represent as I0. This green light is now going to come in contact with my sample, which is placed in the sample holder. The sample holder is mostly called a cuvette. And certain amount of this light is going to get absorbed by the sample. And what comes out of the sample is the transmitted light, which has a certain intensity, which we assume to be I. This is measured by the detector. The detector then calculates something called as transmittance, that is the amount of light transmitted. This is the ratio of the amount of incident light to the amount of transmitted light. And from this transmittance, we calculate our favorite term, that is absorbance. Absorbance is calculated using the formula. Absorbance is the log of 1 by T. Now the next question is why so? What is the relationship between absorbance and transmittance? So as I discussed by Beer-Lambert's law, absorbance is directly proportional to concentration. Why is this? Because absorbance depends purely on the number of electrons that are present in the solution. Whereas if I look at transmittance, transmittance is the amount of light transmitted. It will not only depend on the amount of light absorbed, it will also depend on the amount of light scattered, because that is also not reaching the detector. The light reflected, that is also not reaching the detector. If I have dirt on the sample holder, it is also going to reflect some amount of light, and that will also not reach the detector. So there are multiple factors that control transmittance, and therefore transmittance does not show a direct dependence on concentration. As the concentration increases, you see an exponential decrease in the transmittance. So now if I have an exponential decrease in transmittance, but I need something that is linear, absorbance, what this kind of relationship do we have? Because it's an exponential dependence and I need a straight line, a linear dependence, I use the logarithmic transition. So therefore, absorbance is calculated as log of 1 by T. Now, how do I use this? So if I have a solution whose concentration I don't know, I take the different concentrations of the same molecule and I measure their absorbance. Then I plot a graph between absorbance and concentration. This graph is what I call a standard plot or a calibration curve. Then I will take my solution of the same molecule whose concentration I don't know. I am going to measure its absorbance, and from the absorbance value on the y-axis, I am going to interpolate from a drop-down arrow the concentration of my unknown solution. Simple. There is another method. When I say that Beer-Lambert law states that absorbance is directly proportional to concentration and path length, if I remove this proportionality sign, I have to insert a constant. This constant, epsilon, is called the molar absorption coefficient. It is defined as the absorbance of a solution of 1 molar concentration in a 1 centimeter path length cuvette. So, if you know the molar absorption coefficient of a compound and you know the wavelength at which it absorbs light, having an unknown solution, I can find out its absorbance, and from the absorbance, using this formula, that is absorbance is equal to epsilon Cl, I can find out the concentration of the solution. Thank you for watching this video. Hope you understood what I was trying to explain. If you like my videos, please subscribe to my channel, and if you have any doubts or questions, you can put it in the comment section. I will be happy to answer them. Thank you.